I didn't know how to do that.
Okay, so yesterday, because of our little tornado drill, we didn't quite make it through everything I hoped. I finished up with the example 4, right, where we got down to that idea of the square root of x squared, which is the absolute value. So you had to use the positive x and the negative x. So we got those two asymptotes. You know what I'm talking about? Okay. Bill, you know what I'm talking about?
More or less.
More or less. Okay. I graduated with a girl named more or less. Serious. More or less. I mean, not more or, but more.
And you like spell it on the board. M-O-R-A.
Moira?
More or less.
More
Yeah.
I'll let you use a little creativity, but for Dad, an interesting name. So let's talk about that. We went over that one. Example 10. Draw that out. Figure that one out. Come on. There's another one I want to look at. The idea that, again, we're still operating here in 2.6. Example 10 talks about the limits as x goes to infinity of, I think it's x squared. Yep. Minus x. All right. So part of the deal here is, and we did these yesterday, is the limit laws don't apply when you're dealing with infinite limits, right? There's those limit laws that talk about how you can split it up and all those kind of things, and they just become, you can't deal with that, right? Because we can't just do direct substitution there. We can't just say, first of all, you can't just say, wow, I mean, infinity squared is infinity, and then minus infinity, and oh, we just get 0, right? Anything minus itself? It's fair, right? No? So we can't do that necessarily. So if you see what they do there, they actually split it up there. You can't get a number when you deal with those in that manner. So as you see there, you're doing the first step down, they say you can't just go limit as x approaches infinity of x squared minus the limit of x as x goes to infinity, right? You can't say, oh, infinity minus infinity, fantastic, 0. All right, you can never get a number that way, right? That's a no deal. Okay, we can't have that. All right, so what you'll see there is the limit, they factor it. I'm walking too fast, apparently. So we have this situation. Now, are we able to do it, or are we able to plug in or think about the idea of what infinity does now? Infinity times infinity would just be infinity. So we end up with an infinite idea there where you can plug that in, right? If you're thinking about plugging in or going to infinity and you get a number like 3 or 7 or something like that, you got a little bit of a problem, right? So be clear on that. The last example I want to talk about from 2.6 that we didn't get yesterday was in the book, example 12. And what they say there is sketch the graph, and we can cheat a little bit because the drawing's already there, but x minus 2 to the 4th, x 1 cubed. Okay, and this ties into algebra and the pre-calc part as far as if we had to sketch this, first of all, it's a polynomial, right? That I think should be pretty straightforward. What can we guarantee, or what do we know is the most important thing when it comes to sketching polynomials? The roots. Okay, that's going to help us make a really accurate sketch. What else do we need to know? Degree. And last but not least, infinity and behavior. Okay, so what last piece of information do we need for end behavior? And behavior, EB, and behavior. What's the last piece of information we need to know? What do we need to know to be able to answer that question like that?
The first class.
No.
Even or odd.
Like the degree? Is even or odd? Any odd? All right, leading coefficient. Because remember, right, which way it opens is determined by the leading coefficient. Okay, so without doing a whole lot of work, what's the degree? Four, 8, 2, 4, 6, 8. Okay, 4, 8, 12. We're going to do multiples of 4. What are we working here?
See how it would before.
You see how it wouldn't before now?
It wouldn't.
Okay, that's good. I mean, you can see why it's not 0, too, I hope. Which one is it? 8. Okay, it is 8, right? We've got, if we were to write this all out, we'd have 8 sets of parentheses. And that would be like awesome foil, right? That'd be a ton of fun. But I guarantee it's x to the 8th. And I guarantee my leading coefficient is 1. You okay with why it's 1? Okay. There's 1 here, all the x's. Okay, so degree is 8. What does that mean? They're both going up or both going down. Because my leading coefficient is positive, right? Because my leading coefficient is positive, they're both going up. Some stuff happens in the middle. Okay, I have roots of 2, -1, and 1. So -1, 1, and 2. Now, start drawing crossing the x-axis at those points. Kelly says, yep.
Yeah.
Lynn says, nope. Why not? Okay, multiplicities. Oh man, multiplicities. What happens here? Because it's got even multiplicity, it bounces. The pre-calc book says, you don't know. It says it kisses the x-axis. Okay. It was touching, isn't it? Very touching. So, we come down here, through here, bounce off, and up. And again, I didn't label anything on the y-axis, so you can see in the book, right, it goes down a lot further than what I've drawn there, but you can get those kind of things. So, sketching it is going to be important here because this one gives us a little more information than we might be given another test question about infinite limits. Right, we can write the limit statements. I think it asks. Find limits as x approaches infinity, negative infinity. So limit as x approaches infinity of f of x is infinity. And then the limit of f of x as x approaches negative infinity is negative infinity. Positive infinity.
plus or minus, and feel like your best approach is plus or minus the 30. Bringing up the right.
I will accept that. I will double check on whether the AP nerd will accept that. AP gods of, I don't know where they meet now. They don't meet, they used to meet in Kansas City, but now they can't meet, right? So I don't know where the nerds all get together. So I was like, oh man, you should go do grades on time. Yeah. I don't know. I've been to a couple of conferences and I look around. I don't like people that much. Okay. So, from another example, let's say I tell you f of x is all right, let's say I told you this. Hey, f of x is an even function. Okay. The roots are 3 and 4, right? 3 has a multiplicity of 2, and 4 has a multiplicity of 1. That's so good. Sketch that graph. Sketch that graph. Not your finger, right? On an actual piece of paper. Doro over here. Here's back to the band. It looks odd, like strange.
No. There's even more roots than I looked on.
Okay, so here's the deal, right? These aren't the only roots. These are just some of the roots. Because this tells us okay, now I didn't include even function, but if it's an even function, what does that mean? Mirror image. Okay, are we okay with that? Even now, I was kind of generous on this one because I gave you multiplicities that hopefully stuck out as going, well, that doesn't look like it's even, right? I could have given you this, this multiplicity of 6 or something like that. You have to pay close attention to that because being an even function makes it a mirror image, which means you got some additional roots. All right, so 3 and 4. You know what the other ones are? -3 and -4. Very good. -3, -4. All right. Now, without some additional information, we need to know some leading coefficient stuff, right? Now, yeah, what do you want leading coefficient to be?
1.
All right. 1. What's the equation? 1. What's the first term?
Yeah.
right? Here's 3 degrees.
Oh, yeah.
Mirror image, I've got to have another 3. Okay? So again, and I'm not saying you got to see that right away, but the important part is when we're given information about a function, be really critical about that information. Now, this is very much an algebra 2 type setup. This starts to build on some requirements and things they might ask you. Okay? Makes sense? All right, so a little bit of wrap up on section 6. We're going to look at some questions because apparently you guys have some, huh?